Hi guys, let's talk about the coherence. Let's talk about the coherence in biological systems. And coherence is a very fundamental property of quantum mechanical systems. And we would like to stop looking the accidental nature of biological systems. What we would like to start is we would like to start looking the biological life as something extremely coordinated, extremely cohesive in nature. And this will be something that we would like to understand. We would like to understand that biological systems are not actually, they are not actually accidentally coming in action. They don't work in accidental sense. But there is a coordination, that there is an overall coherence of these biological systems that leads to this biological pattern of life. So that's what we are going to talk about. So what we have is we will be trying to understand the coherence in the very biological systems, the systems that are made of the ordinary matter, that are made of the things that are surrounding us. So, so the point is that we will be talking about these coherent quantum mechanical systems, because fundamentally they appear to be quantum mechanical in nature, because everything has a quantum mechanical start, because everything is made of atoms, everything is made of these building blocks, these fundamental particles. And if I tell you that if I tell you to imagine an orchestra, I'm not telling you to imagine the music. I'm not talking about a musician, just one musician. I'm not talking about the two musicians. I'm talking about the hundreds. Now imagine that these hundreds of musicians, they play. And without they play without a conductor. They play without the sheet music. They play without a rehearsal. And yet, and still, they remain perfect. They remain perfect in time. This should not be possible. When we create something classical like this, we have to plan a lot about it. But yet, inside every living cell, inside every biological cell, something like this is happening, something like this is going on and on. And this is that coordination. This is that coherence. This is the coordination that's coming from this quantum mechanical coherence. If you look at it, it's fragile. The fragile, mysterious, but at the same time, coordination. A fragile, mysterious coordination that allows life to act as a whole thing, as a whole process. Now, instead of falling apart into the noise that's mingling, that's there, first, let's try to understand what coherence really means. What am I trying to tell when I'm saying coherence? In literal sense, coherence means togetherness. But mathematically, they have to have a relation. They have to be in the same phase. In quantum mechanics, we have an arbitrary way of understanding it. In quantum mechanics, waves stay in step. And the waves, they remain aligned with respect to their phases, with respect to their initial angles. And when this information is basically shared across the space, instead of acting independently, you don't have these quantum mechanical particles acting independently in space. Even they are not the point particles, they are making your fields. The parts of a system behave as an extended entity. As an extended entity. Let's try to bring in an example. Let's try to take an example of rowers on a river. You have a boat and you have rowers. So what am I trying to tell here is that if I tell you to imagine this long boat and there is presence of many rowers on this boat. Now, if they row randomly, what do we expect? If there is random rowing of different kind of people sitting in the boat may spin, and there is a very good chance of the spinning of the boat. The boat may spin in a circular orbit, in a circle. Now, if they row together, if they pump in the water together, the boat guides effortlessly. You have to give less efforts and your boat is doing the job. It will take the direction that you are interested in. Now, in this example, what we have the coherence. Coherence is synchronizing. It's the synchronization. It is synchronized, rowing at the quantum levels. Particles are not just present, as if they don't know each other, as if they don't have any communication, as if they are completely independent of each other. They are basically the linked phases. They are phases that are linked with each other. Now, coming into the living systems. In living systems, we have coherence. It is this coherence that allows energy and information. It allows the energy and information to move efficiently. The rover example that I have given you, quickly and purposefully. And if we imagine this thing going on without coherence, or I can say that without coherence, life would be slow. It would be wasteful. It would be fragile. So this way we can understand the importance of the coherence in the biological systems. Now let's go with a surprise. The surprise in warm and wet life. Warm and wet at the same time. The quantum coherence was once believed to exist only in extreme cold and isolation. The quantum computer is an example. That's at IBM. It works at very, very low temperatures. But life violates that expectation. Cells, they are warm. And cells, they are noisy. If you have a small quantum of noise outside that quantum mechanical computer, you will lose the calculation. But this thing is not happening at the room temperature. Cells are wet. And yet, you are able to see this coherence. To have coherence in a quantum computer, you need all of these things: low temperature, zero noise. This has really shocked our understanding. This has really shocked our learning. This has really shocked us. And the very example is photosynthesis. And photosynthesis is, I'm sorry, I got a man, is a process that we understand that what photosynthesis is. It's just a transformation of energy into that food. And this process happens with coherence. Now, what happens when the sunlight, when it hits the leaf of a tree, energy must travel through the dense molecular networks in the leaf. You have a leaf, the sunlight is falling on it, the energy is falling on it, and it must take time to have a traveling to reach the points, what we call as reaction centers. It has to cross the dense systems. And if we think about this process classically, this kind of thing should be inefficient. It should not be possible for energy to be that much fast. Okay, let's take another example. A child in a crowded market. You have a crowded market. You imagine that the child is trying to find their parents, but the market is very, very crowded. And what we expect in a crowded market, walking randomly would take forever. Basically, it would take infinite time. It would take forever. But now imagine this child. Assume this child spreads as a wave. Spreads as a wave and chooses all the paths. Explores all the paths. Once the child explores all the paths at once, it finds the right path. All other paths collapse. And it takes this just one path. And this is what happens in photosynthesis. This is what happens in this basic phenomenon of transfer of energy from solar to the biological. This is something that makes this photosynthesis happen. Energy behaves like a wave. It samples many pathways. It samples them all. It doesn't take all the paths. It samples them all simultaneously and finds the most efficient and finds the most relevant and finds the most constructive path to hit the center where it can cause that reaction. This is coherent energy transport. This is how nature works. And nature is working quantum mechanically. It's not like that this child is guessing. No, it's not guessing. Where should I go to hit the target? It knows. It knows because of coherence. It understands, it realizes because of coherence. Coherence keeps options connected. I think we feel as if we are getting an idea. And a simple way to say it is energy does not hop blindly. It doesn't do the things in a random way. The randomness, it flows intelligently. It flows efficiently. It flows extraordinarily. It flows unimaginably. It doesn't flow by our thoughts, but it flows by a coordination of quantum mechanical system. So, coherent energy transport that we have, this coherent transport is present in our cells also. And it's not alone the photosynthesis where this coherence is taking place. We have many evidences, and many evidences suggest that coherence may play roles in the respiration of cells, what we call as cellular respiration, in the dynamics the dynamics that's played by the proteins, what we call as protein dynamics, the transfer of signal inside the cells. This coherence must be there. It should not be like random kind of thing going on. And cells move energy with precision. They do it with precision. They do it with accuracy. They do it with legacy. They do it with the greatness, despite there is an observable chaos. Let's take in this coherence to the whispering in a hallway. If I imagine a hallway, okay, and one person whispers at one end, at one corner of that hall, and instead of fading his whisper, the whisper that he gives arrives clearly at the other end of the hall path. We are trying to understand the coherence. We are trying to understand this coherence which is happening at very, very fundamental level. And it is basically this coherence. The coherence allows signals to persist without being drowned, without being dead, without being gone, without being drowned by the presence of noise. In cells, coherence helps energy and information to sustain. It's this beautiful quantum mechanical phenomenon that makes it happen. And it makes it move without losing the direction, without losing the destination. Life is not loud. Hey, come on, come on. No, it's not. Life is a coordination. Life is subtly coordinated. Coordinated in all sense. If I take a day-to-day example of walking through a crowd again, you have a crowd and you walk in that crowd. And what do you expect? What you do is you walk through a street. And let's assume that this street is busy. You do not collide with everyone. And your movement adjusts smoothly, feebly, and almost unconsciously. You have a balanced pattern. Maybe there are accidental shots, but you are trying to reset it. And maybe this is the way that our brains maintain the coherent patterns of motion. It has that tendency that makes it legitimate, that makes these legitimate patterns in our brain. And what's happening? You have multiple signals. The multiple signals stay phase aligned long enough to guide an action. This is what we are trying to understand at the macroscopic level. This is a macroscopic coordination that mirrors from the microscopic coherence. The coherence is not coming from chaos, it's coming from the coherence itself. And this coherence is seeming like frugality. We sometimes feel it as a frugality of the coherence. And this coherence is so delicate that in a humanly constructed quantum computer, a small heat may disrupt it. A small noise can distort your information in a quantum computer. The thing that looks random, the random motion, breaks the alignment in what is being the so-called artificially built in the form of a quantum computer. This raises a deep question. How does life protect this coherence? It really amazes us. How life protects this coherence, which we fail to do, and using billions of dollars. Life does not freeze itself. It seems like instead it uses it. And it has that structured environments, a structured environment. It has a rhythm. It has the rhythmic motion in it. And protect you maybe protect you molecular shields. So surprising. If I take you back to that example of candle, but I want to keep that candle in a wind now. You have a candle, and I imagine this candle in a windy place. The wind is blowing it. Now, instead of blocking the wind, you place the candle, you place a candle inside a lantern. You have a lantern, you keep your candle inside the lantern. The flame survives. The flame does not survive by isolation, but by the intelligent shielding that is surrounding this flame. How can we understand it? What am I trying to tell here? Proteins and cellular structures that exist in us, that exist in biological systems, they act like quantum lanterns. You have a candle in a lantern, and these things act as quantum lanterns. They shelter the coherence just long enough, just true enough, just enough to be useful. Life does not demand performance. It doesn't. What it does is it needs coherence. And it needs that coherence only briefly, for a very, very short span of time, time and again. And why this short coherence is enough? Why I'm trying to coin this word to understand it. Life does not require an eternal coordination. A coordination that's eternal in nature. No, this coordination is there for microseconds. This coordination is there for milliseconds. And this coordination in those milliseconds are sufficient. And sometimes you can go to microseconds, you can go to nanoseconds. That framework of time is enough. That framework of time is sufficient for the life to guide energy, to select the path. See the fastness of this phenomenon, to trigger the reaction in the leaves of a tree when there is photosynthesis, to bend a protein molecule, to have a coordination in DNA molecule. Then coherence can vanish. Life moves on this way. It goes on and on in the actions of the times of the scales of milli and microseconds. And that invisible action that we are trying to understand, that invisible action goes on and on, that continues. No cell understands the coherence. No organism commands. No organism commands this action. The coherence, it basically evolves. it emerges because the physical laws, the laws of science, the laws allow it. The laws of physics allow it. Because the laws of physics allow it, the biological systems exploit it. This is the invisible action again, for which there is no number that can be put on and can be demonstrated. It is unseen. It is uncontrolled. It is essential. It cannot be translated into a number. It cannot be measured. And why this change? Why basically this changes our perception? Why it changes our perception of the self-life? Life is not merely a chemical reaction. It's not that chemistry. It's not that biology. It's not those complex things. It is basically an organized quantum mechanical activity. And this activity is operating at the edge of the randomness, at the edge of the disorder. And what you have too much coherence, you have rigidity, and you have very little chaos. So what is happening? Life is a balance between a chaos and the coherence. And with this, I would like to have a closing of what we are trying to learn here in this framework. Inside every living system, there is a quiet harmony. And this harmony is not imposed. It's not accidental. It has its structure. And at the same time, it is not controlled. It's just maintained. It's maintained just long enough. So quantum coherence does not make life magical. It doesn't make it magical. In real sense, everything seems magical. It makes life possible. And when coherence fades, when coherence dissolves, when coherence dies, life does not fail. It simply finds the next. It finds a next moment of coherence. It finds a next moment of order. It finds a next step to align again. That's it. That's what I feel, what I understand, and what I'm trying to learn. I hope you like it. I hope you subscribe, and a very bye.